Hi, hello. Okay, so the reason we're making this video is sort of to help people get started with Programming Assignment 1. Not that you shouldn't have started, but hopefully we can just say some interesting things or, well, helpful things that should make it a bit easier to get through at least the first alignment part of the assignment. So a couple of things from the handout that we should talk about. Reading and references. You should read these and refer to them, especially this Collins one if you're implementing IBM Model 1 and 2, which you will be. That's super helpful. Good to know. Yeah, PMI. We've had a bunch of questions about the PMI model on Piazza and like in office hours, and I just wanted to say that as long as you're doing something sensible and you're getting a reasonable AER, I wouldn't spend too much time on it. It's sort of more important to move on to like Model 1 and Model 2, which are more difficult and more interesting. Yeah, okay. So a majority of the time in this video is going to be spent talking about Model 1. And what we're going to do is step through a really small example on a tiny corpus and just figure out exactly what Model 1 is trying to do. So yeah, let's talk about the parameters. So Model 1 is just described by these two parameters. The Q ones are the distortion parameters and these translation probabilities. And like we said in class, in Model 1, the Q parameters are set to be just uniform over source positions. So we don't have to actually learn them, but we do have to learn the translation probabilities, which we will learn using EM, and we'll talk about that in a moment. The reason we have this +1 here is because of the null word, and you're going to add a null word to every target sentence in your training set. And what are the things that we have to say about that? There's just a bunch of ways that you can do that, and really, as long as you're consistent, you can sort of add it into like your sentence pair object, or you can keep track of count separately, or you can really do whatever you want as long as you're sort of counting the things that the model wants you to count. Also, when you're actually doing your alignments, if you have an alignment to the null word, make sure that you don't actually output that, because the training data is labeled sort of without the null word in it, so it's just going to ruin your AER. So yeah, only put alignments into your alignment object if they are two non-null words. Cool. Okay, so we're going to now talk about these translation probabilities and how we learn them with EM in this spreadsheet. Okay, we'll share this with you so that you can sort of play around with it and just see where things are coming from and look at formulae and stuff. But okay, so what's happening here is we have this very tiny corpus of two sentence pairs in Spanish and English, and what we're going to use IBM Model 1 for here is to learn these alignments. So we want to learn that Casa aligns to house, Verde aligns to green, and La aligns to the. This example actually came from the textbook. It's from chapter 25 of the Joravsky and Martin book. So you can go look at it there or follow along there, or yeah, that's where it's from. Cool. So we are going to do EM, which basically means we're going to start off here, count a bunch of things in our corpus, then go here, and then estimate our parameters, and then use these new parameters to count more things in our corpus, and then re-estimate the parameters again, and keep doing that a whole bunch of times, and that's going to be EM. So let's start here. we have to initialize all our parameters, and like we said before, Q parameters are already fixed. We don't have to worry about them. And luckily we have like a super tiny corpus, so we've actually enumerated every single parameter of this model here. And like we said in class, model 1 is practically convex, and we can sort of initialize it however we want and expect it to converge to an optimum. And the way that we've decided to initialize it is uniformly. So we have this conditional probability distribution for the word green translating to a bunch of different Spanish words, and these probabilities all sum up to 1. It's super nice. And we also have conditional probability distributions for all other English words as well. Cool. So now we're ready to start doing the actual EM stuff. Oh, just another thing to note is this is fantastically simplified, but so we will actually not have the null words in here. You will have them later on, but hopefully that won't, like this will still be helpful even though it's different. Okay, so we're going to start with our E step, and what we've done here is enumerated a bunch of alignments for the two sentences. So here's one sentence pair and here's the other sentence pair, and we've enumerated all the alignments that we really want to care about. And you've seen alignment grids in class before, but basically what this is saying is we've aligned casa to green and we've aligned verde to house. And right, so we're basically going to go ahead and calculate probabilities for all these different alignments for these different training examples. So there are two different kinds of probabilities that we're going to do. This first one is the probability given to this training example by the existing parameters of our model right now. So the way that we do this is for each word, for each alignment, we get the translation probability for it. So for example, here we want the probability of the word casa giving green. So we get that from up here, where we initialized it before. And here we have the probability of verde given house, which we got from over here. And when we want the probability of the entire sentence, we basically are just going to take a product over all the words in the sentence, which is this, which is happening in this cell here. And this gives us the probability of this sentence with this alignment according to our model so far. The other probability that we're going to need is the posterior probability of these alignments given the sentence pair. And the way that we're going to get that is by looking over all the possible alignments for this sentence pair, and we just take the probability for this alignment and divide it out by, we basically just normalize it by the sum of the probabilities for all the alignments. So here it's this probability divided by the sum of this one and this one. So this is kind of boring. Everything was uniform before, so all of these are very predictable. They're actually all exactly the same. So here we have the probability of law given the, which we got from there, and then casa given house, which we got from there, and then we did the same product thing again and the same normalizing thing again, and that's all that's happening. Cool. So that's the first part. We got our probabilities, and then the next thing we're going to do is we're going to collect fractional counts. And the way that we do this is we're counting all the times that the word green was, we're counting all the times that the word casa was aligned to the word green to give us this count. And we're going to take the posterior probability of that alignment and add it up. So here, casa is only aligned to green once. So we're going to grab that value here, and that's going to be this count. So that's what we got. But for example, casa was aligned to house twice, once here and once here. So we're going to get the sum of those two. And we count all those up, and that's what's happening in this entire table. And we also sum these up to get marginals. Right. So that's the E step, and now we go to the M step, where basically we are trying to re-estimate all our parameters, and we're going to do that by taking all these counts that we got in the previous step and turning them into probabilities. So we're just, for example, for this translation probability, we're going to take this count of casa given green and divide it out by the marginal, which, okay, gives us the same number, not interesting. But here, say casa given house divided by this marginal is going to end up giving us another valid conditional probability distribution, which is great, because now these are new values for all our t parameters. And it's interesting to note that although we started with uniform probabilities up here, that uniformity is already broken in one step. And there are things like, for example, you would expect law to be a poor translation of green, and indeed it has a very low probability. So yeah, the model seems to be behaving and things are working out well. So that's the end of the first M step, which means it's also the start of the next E step. But really, there's not very much to say, because we're doing exactly the same thing, except our t values come from up here. So here's this probability of casa given green coming from here, and then verde given house coming from here. And then we do this product again, this normalization again. And now we have our new posterior probabilities. And we go ahead and collect the fractional counts the same way. Casa given green only occurs this one time, but casa and house are aligned twice again, so we grab both of those, and that gives us this value, collect the marginals, and normalize them out to get new t translation probabilities. And so things are looking up now. We have verde given green as 0.67, which is great, and so does casa given house, and everything's beautiful. Well, it could be soon, because yeah, so we would continue this for a whole bunch of iterations, and we sort of leave it up to you how you want to do that. You could come up with a fixed number of iterations that you want to do and decide how many that is by tuning on your dev set, or you could actually compute the log likelihood and sort of stop iterating once it stops improving, or basically what I'm saying is just iterate until convergence and define convergence in a reasonable way. So that's all we have to say about IBM Model 1. Let us know if you thought this was helpful, or if there are other things that you'd want us to make videos about, which we could try to do, but I'm not guaranteeing, or if you thought it was not helpful and you think we could be helpful in a different way. But yeah, come to office hours, come to coding sessions, and good luck with the rest of the assignment.